Hello again. This is about Heltec HT-M2808 Helium miner, and the most annoying part about this is the low reception possibilities. You see the version 1 or 01, I don't know, version 1 anyway, and 1.1, they have a problem because there is a single SAW filter. Okay, here we are. So the problem with version 1.1 and version 1, of course, it's this here. It's a single SAW filter. The signal is coming from the antenna here on pin 11, right here, and then goes to the pin 9. You can see it. We have an LNA amplifier here, low noise amplifier. Then afterwards it goes to this filter. This is a SAW filter centered in 868 megahertz. Anyway, it's 3717, and of course it's running to this two ICs. Okay, the problem is that the whole signal from the antenna, the whole bunch of frequency, consider the radio environment like a sandwich of frequencies from, I don't know, from 100 kilohertz to 2.5 gigahertz like we have in our Wi-Fi at home. So all these frequencies, that's including the GSM frequencies and taxi and ambulance and everything, all the radio environment is going unfiltered in this amplifier. So we need strictly 868 and around, plus minus 3-4 megahertz. The problem is that all these radio frequencies, all this bulk radio frequencies are absolutely flooding the low noise amplifier, and the rest of the ICs can't take from there, from all those frequencies, radio signals, can't pick up the right ones. That means LoRa signals. And one of the solution, of course, is to insert here between pin 9 and 11 a filter, or even better, to insert another low noise amplifier, the right filters. Okay, but the story is that I asked a friend of mine who's got a radio like this, you see, I asked him to help me to search the environment, the radio environment around 868 megahertz. That's the main frequency for Europe. This is a really nice toy, but I consider a tool. Okay, this is an RTL SDR. That's homepage. A lot of interesting things about this. In fact, it's a radio, but because it's driven by software, it can do a lot of wonderful things. And of course, the good thing about this is that it can see, or better saying, listening 868 megahertz. And let's see what we could find. First of all, these images are in the middle of the town. They are from Bucharest, and as you can see, there is a lot of radio traffic there. And there we are. You see, we got 868 right here. These things here, you see these bursts, these lines here, I think they are LoRa signals, the beacons. These are beacons, in fact. But look over here. It's absolutely in proximity, close proximity. 867.6. This signal here, and look the velocity of this signal. It's exactly near our band, the band needs, LoRa needs. So this one, it's covering, it's like looking in the night to a flashlight. or worse, into the car light, front lights. Okay, so this is just a single one, continuous. Okay. Suddenly something else appeared. You see exactly on the 868.2. I don't know if it's related to beacons, but after my opinion, it's too long for a beacon. Okay, and that's another one. You see, to have all of this clearly represented on the screen, we have to use this row reception. So there's nothing related with FM or AM, the really classic radio and so on. And here we go. Lower in 700.8 band or frequency, I'm sorry. And there is another continuous signal too. And over here, this is really over. This is the 900 megahertz GSM spectrum. Look there. Look of this, it's a widespread signal, pretty high dB here, and this reception is done with a very simple antenna. So I don't know, what can I say? It's a crazy radio environment. We can't do anything about this but filtering the signals as good as possible. So this is 900 megahertz, the GSM radio signal. Another picture. In fact, this is a screenshot. Well, I don't have this radio, so I'm not sure what to say about. It's not here. I asked this friend of mine, to do this for me, because I just want to check my theory about. And once again, here we have the LoRa beacons, and I don't know what is this. It's in the same range or spectrum, and that's a LoRa too. Maybe this is from a sensor, long range sensor, something. I don't know. Anyway, this one bothers me. It's so close to the signal. Okay, some others. And look, this one on 868.2 something became much more evident. And here, it's the LoRa beacons. Look, one, another. So finally, that's the story. I think the best way to get rid of everything else is to cut this frequency, from down here to up here with a good filtering and good amplification. And then not only Heltec, but all the miners are affected about this. This kind of situation like this, people talking, whispering, low voices, and suddenly we have a brass orchestra coming in. You can't hear those guys anymore. They are covered with noise. You can't reach their information anymore. Okay, so that's it for now. I'm waiting for my radio, and I'll do some more tests in the area. But I think this is a really good idea for you to understand what's happening around your frequencies. Having a good directional antenna, we can mask this kind of collateral signals. You just turn your antenna to a certain position when the others are just disappearing. Okay, that's it for today. I hope it's useful. Please like, subscribe, and most of all, don't forget to have fun. Bye bye.